Find f prime of x given that f of x equals 2 to the x plus 3 to the minus x quantity to the sixth. Okay. So this problem is not that difficult, but there is lots of opportunities to mess up, to trip you up. Human performance traps, if you will. So the first thing you might think is, okay, there's an exponent, I'll just distribute it. So you think of something like 6x plus 3 to the minus 6x, and that you can't do that. Not allowed, because that's not the way this exponent works. What this is really saying is you have this polynomial and ... you're multiplying them by each other 6 times. This would be 6 of these. And so what you do is you'd have to FOIL each of these and then combine it into one giant massive polynomial. And we don't want to do that. That is terribly cumbersome and difficult. So what we're going to do then is we're going to do the chain rule. So the chain rule is f of g of x prime equals f prime g of x times g prime of x. And normally I'm not this formal about the chain rule, but it might be useful here. So in this case, f of x will be x to the sixth. So we're saying is this right there is x, that's the 6, x to the sixth. So f prime of x would be 6x to the fifth. We just bring the exponent down and then subtract 1 off of the original exponent. So now, though, we need to find out what g prime of x is. And we should probably state what g of x is as well. So if we have g of x here, we would say that g of x is that guy in the middle. So 2 to the x plus 3 to the minus x. Now this is the tricky part. Well, the trickiest of the parts. So I'm just going to write it out. So we'll have natural log of 2 to the x plus natural log of 3 to the x times negative 1. And what I'm doing there is I'm basically using a rule for how to take the derivatives of something that's to the x exponent. To the exponent of x. So the way this is done is I'm going to say if we want to take the derivative of 2 to the x, then this would be the same as taking the derivative of e to the natural log of 2 to the x, which would be the same as taking the derivative of e to the x natural log of 2. Well, we know the derivative of e to the x, that's just e to the x. So we have e to the x natural log of 2, and then by the chain rule, then we'd multiply by the derivative of the interior, which is the x ln of 2. Derivative of x is 1, and natural log of 2 is just a constant, so we're left with natural log of 2. Then we rearrange things again. We get e to the natural log of 2 to the x times natural log of 2. The natural logs cancel. I wanted orange. And I'll draw another line. There we go. And we're left with 2x natural log of 2. And your question is, wow, do I have to, should I derive it or should I just memorize that that's the case? That's actually a pretty good question. I know it just because I've done it so many times. But like for someone just studying calculus for like the first time and becoming good at it, it might not be worth your time. So the AP Calculus exam has about like 50 multiple choice questions, plus free response questions. But with the free response, you might get maybe 1, 2, possibly 3 at most questions like this involving this x as an exponent. So it's like, well, you have 3 questions. That's what, like 6% of the total? It's like, maybe. But if you know the process of deriving it, then it's like, well, you'll still get the right answer. You'll just be slower. And so for me, I would recommend memorizing that 2 to the derivative of 2 to the x is natural log 2 to the x. I'd be familiar that that's the answer. And so what I would do is I would actually derive using e to the natural log every time. And then I'd be familiar enough with the correct answer so that if I get the wrong answer, I recognize that it's wrong and I'm able to go back and correct it. So that would be my advice. But you could also just be like, yep, I'm just going to memorize this. Boom. Put it in my memory box. New penguin on the iceberg, so to speak. And that's pretty reasonable too. Okay, so going back, this should be a negative because that negative should never have been lost. And then the negative 1 comes from the chain rule. Okay, so now we have f of x, f prime of x, g of x, g prime of x. And when we put all of this together, we will get something along the lines of, I like blue. Blue is a good color, very solid. So we have g of x, which is this one. So we have 2x plus 3 to the negative x to the 5th times 6 times g prime of x, which is this one. Give myself a little bit more real estate here. Zoom in slightly. Oh, color in that dot. Natural log of 2 to the x minus... Oh, man, okay. Natural log of 2 times 2 to the x minus natural log of 3 times 3 to the negative x, parentheses. Okay, and this would be our f prime of x. Yes. So one of the things I do that's kind of confusing here is they're like, well, here's f of x. And then I use f of x to mean something else. So, answer. And the reason that happens is a lot of people use f of x, and then I use f of x whenever I do the chain rule. And so that kind of gets cumbersome. Like, wow, I should really pick some different variables that I use every time that I do for the chain rule. True. That is a good suggestion. I probably won't take it, but it's good advice. So the answer is this, which is f prime of x by what the problem is asking for. Okay, so now that we have the problem, let's actually match it up. Come on, yes. Maybe if I rotate it a little bit, compensate for my right-handedness, probably can get rid of this arrow and the line. Okay, so this one is 6, check, 2x, check, 5th, check, natural log of 2, also check 2 to the x minus natural log of 3. Yes! Okay, so it'll be this answer right there. So to backtrack real quick, we were given f of x, we're asked to find the derivative, and the way we did that was we're like, all right, we have kind of a nested function here. So we have a power rule, and then we have x used as an exponent. So we use the chain rule, 6 comes down, get a 5th there for the power, the interior stays the same, then we multiply by the derivative of the interior, which natural log of 2 to the x minus natural log of 3 to the x. Yes, and that's how this problem is done.